Welcome to Module 5, Physical Security. This module is one of the most important and comprehensive sections of the Certified Protection Professional Program by USIS International. Physical security forms the foundation of how organizations protect their people, assets, information, and operations in the real world. Throughout this module, we will explore how security professionals design, implement, and manage systems that prevent, detect, delay, and respond to threats. The concepts covered here are not only essential for the CPP certification exam, but also for practical security leadership in modern organizations. In this first video, we will walk through a high-level content overview of the module. This overview will help you understand the structure of the topics and how the different chapters connect to build a complete physical security management framework. This module provides a comprehensive reference covering enterprise security risk management, physical and electronic security systems, structural measures, and the critical role played by security officers and human elements. It begins with the foundational principles that guide physical security programs and gradually progresses toward more advanced integration strategies. You will learn how physical security is designed not as a collection of isolated measures, but as a coordinated system that integrates technology, procedures, architecture, and human resources. By the end of this module, you should have a clear understanding of how modern organizations build layered security systems that effectively protect assets while supporting operational goals. This module is organized into 4 major areas that together form the core knowledge required for physical security management. First are the foundations, which introduce key concepts in security risk management, the functions of physical security, methods for planning and conducting assessments, and ways to measure effectiveness. The second area focuses on design and architecture. Here we examine basic design concepts, the factors that influence security design, and how security architecture and engineering integrate protective measures into facilities and environments. The third section addresses systems and people, including structural security measures, electronic security systems, and the role of security officers and human factors in maintaining effective protection. Finally, the module concludes with project lifecycle considerations. This section explains the principles of project management, systems design, implementation, and the follow-on support activities necessary to sustain security programs. Together, these topics provide a structured path from foundational concepts to practical implementation of physical security programs. In order to design effective physical security, we must first understand the concept of security risk management. Enterprise Security Risk Management, or ESRM, is a holistic and stakeholder-driven approach that aligns security activities with the organization's overall risk management framework and strategic objectives. At the heart of ESRM are several core values. These include protecting organizational assets, supporting business operations, and enabling informed decision-making regarding security risks. Another important element is stakeholder engagement. Security leaders must work closely with business units, management, and operational teams to understand their concerns and priorities. Security is most effective when it is aligned with the needs of those it serves. Finally, strong governance ensures accountability and clear responsibilities in managing security risks. Governance structures guide policies, oversight, and decision-making processes that support a consistent and sustainable security program. Together, these elements provide the strategic foundation for all physical security planning and implementation. Physical security exists to protect people, assets, and facilities from a wide range of threats through a layered and integrated protection strategy. To achieve this objective, physical security relies on 3 core types of security measures. The first category is physical security measures. These include barriers, locks, structural controls, and other design elements that physically prevent or delay unauthorized access. The second category is electronic security measures, which include surveillance systems, access control technologies, intrusion detection systems, and monitoring tools. The third category involves personnel and guard force measures. Security officers, patrols, and response teams provide the human presence needed to monitor activities, detect suspicious behavior, and respond to incidents. Supporting all these measures are peripheral systems and interfaces, which integrate these layers into a unified security framework. When properly combined, these layers create a defense in-depth approach greatly enhancing overall protection. A key responsibility of security professionals is to plan and conduct physical security assessments. Assessments help organizations identify vulnerabilities, threats, and potential risks within their facilities and operations. One important element is the use of risk assessment models. These models evaluate the likelihood of threats and the potential impact on the organization, helping security managers prioritize resources and mitigation strategies. Another component is security surveys, which involve systematic inspections of facilities, processes, and existing security measures. These surveys help identify gaps in protection and opportunities for improvement. Once assessments are completed, the next step is applying the results. The findings must be translated into actionable recommendations such as improved security controls, operational procedures, or system upgrades. In some cases, organizations may also rely on outside expertise, including consultants or specialists, to provide independent evaluation and technical insight. Overall, effective assessments ensure that security programs remain proactive, risk-based, and continuously improving. Implementing security measures is only part of the process. Organizations must also determine how effective those measures are. This is where physical security metrics become essential. Metrics provide quantifiable evidence of how well a security program is performing. They help demonstrate the value of security investments and support informed decision-making by management. In practice, organizations often track several categories of metrics. These may include system performance metrics, operational indicators, and aggregated data used for strategic analysis. Metrics can also be presented through dashboards and performance indicators, making it easier for leadership to monitor trends and identify areas needing improvement. A well-structured security program typically tracks multiple key metrics, and many organizations implement a broader set of recommended measures to capture a complete picture of performance. Ultimately, security metrics support continuous improvement, ensuring that protection strategies remain effective against evolving threats. Once risks are understood and performance metrics are established, the next step is designing effective physical security systems. Security design is influenced by several important factors. First is the concept of point versus area security. Point security focuses on protecting specific assets or locations, while area security addresses the protection of larger zones, such as buildings, campuses, or industrial facilities. Another important principle is conflict avoidance and balance. Security measures must provide strong protection without unnecessarily disrupting normal operations, employee movement, or customer access. The characteristics of the facility itself also play a major role. The layout, construction materials, building usage, and operational processes all influence the type of security measures required. Finally, surroundings and geographic location must be considered. Environmental conditions, nearby infrastructure, crime patterns, and local threat environments all affect security design decisions. By carefully considering these factors, security professionals can create balanced, efficient, and practical protection strategies. Effective physical security ultimately depends on sound security architecture and engineering principles. Security architecture begins with design foundations. These include defining the security requirements of the facility, selecting appropriate control technologies, and ensuring that protective measures are integrated into the building design from the earliest stages. Architectural considerations also include perimeter lighting, blast-resistant design, and structural features such as walls, facades, glazing, and interior layouts that enhance protection. Another important dimension is the integration of critical systems. Facilities must be designed to address hazards such as hazardous material incidents, contamination risks, and other operational threats. Additionally, infrastructure like emergency power systems ensures continuity of operations during disruptions, while life safety systems support evacuation and shelter-in-place procedures. Ultimately, security engineering ensures that security requirements, operational needs, and safety considerations are integrated into a coherent protection system that supports the organization's mission. Modern physical security is most effective when different protection measures work together as an integrated system. As illustrated on this slide, physical protection strategies typically combine three key components: physical elements, electronic security systems, and security programs. Physical elements include barriers, fences, walls, doors, and structural protections that form the first layer of defense. Electronic security systems add another layer by providing alarms, sensors, access control systems, and surveillance technologies that detect and monitor potential threats. Finally, security programs bring together policies, training, procedures, and operational management to ensure that these systems function effectively. True security integration connects these elements into a coordinated protection framework where technology, people, and physical design operate together to reduce vulnerabilities and enhance overall resilience. Structural security measures form the physical backbone of facility protection. The first category includes barriers, such as walls, doors, windows, roofs, fences, and bollards. These elements define the building envelope and help delay or prevent unauthorized access. Next are containers and vaults, which provide hardened storage for high-value assets, sensitive materials, or critical information. Their design focuses on strength, resistance, and controlled access. Another important component is locks and locking mechanisms. Mechanical and electronic locking systems must provide adequate resistance against forced entry while allowing authorized access when required. Finally, security lighting plays a vital role in deterrence and visibility. Proper lighting supports surveillance systems, improves situational awareness, and enhances overall facility safety. Together, these structural elements create the first line of physical defense within a layered security strategy. Crime prevention through environmental design, commonly known as CPT-ED, focuses on reducing crime by influencing the design and layout of the physical environment. CPT-ED is built around several core principles. These include natural surveillance, natural access control, and territorial reinforcement, concepts that encourage visibility, guide movement, and establish a sense of ownership over spaces. By designing environments where activities are visible and access points are clearly defined, opportunities for crime can be significantly reduced. CPT-ED also relies on tools and supporting technologies, including access control systems, surveillance cameras, and strategic architectural planning. These principles are applied across many environments, such as office buildings, residential facilities, parking structures, automated teller areas, and university campuses. When integrated with traditional security measures, CPT-ED strengthens protection by shaping the environment to discourage criminal behavior. Electronic security systems provide the technological layer of modern physical protection programs. One key component is access control, which regulates who can enter specific areas within a facility. This may involve card readers, biometric systems, or other credential-based technologies. Another important system is contraband detection, which identifies prohibited items such as weapons, explosives, or other hazardous materials. Facilities also rely on physical intrusion detection systems, which use sensors and alarms to detect unauthorized entry through doors, windows, or perimeter boundaries. Video surveillance plays a major role as well. Modern video analytics and networked camera systems allow security teams to monitor activities, analyze patterns, and respond quickly to suspicious behavior. Finally, communications and annunciation systems ensure that alarms and alerts are transmitted quickly to security personnel for appropriate response. As technology continues to evolve, these electronic systems are becoming increasingly integrated into smart, centralized security platforms. While technology and infrastructure are critical, the human element remains central to physical security. Security officers perform a wide range of core functions, including access control, patrol operations, inspection and monitoring, emergency response, traffic control, and escort duties. Their presence not only provides real-time response capability, but also serves as a strong deterrent against potential threats. Within a professional security program, several officer roles may exist. These can include shift supervisors, contract officers, environmental or compliance officers, and specialized physical security personnel. Equally important is the selection and training process. Effective security organizations use structured hiring methods, background verification, and professional training programs to ensure officers possess the necessary skills and professionalism. Ultimately, Well-trained security personnel serve as the operational link between security systems, procedures, and real-world response. The final part of this section focuses on project management and systems design, which are essential when implementing large-scale security solutions. Security projects typically begin with initial planning phases, where requirements are identified, risks are analyzed, and stakeholders align on objectives. The next stage is the design phase, where security architects develop conceptual designs and technical specifications that address the identified security needs. Once designs are finalized, the process moves into contracting and procurement, where vendors are selected, equipment is acquired, and installation plans are developed. Throughout this life cycle, effective project management ensures that security solutions are delivered on time, within budget, and aligned with operational requirements. As security technology evolves, especially with the shift from analog to digital systems, project management plays a critical role in ensuring successful system integration and long-term performance. After the design and planning stages, the next critical step is system implementation and ongoing support. Implementation begins with site preparation and contractor coordination, ensuring that the facility is ready for the installation of security equipment and infrastructure. This is followed by component installation and system tuning, where security devices such as sensors, cameras, access control systems, and communication systems are installed and configured to operate effectively. Before a system becomes fully operational, it undergoes factory and site acceptance testing. These tests confirm that all components function according to specifications and that the system performs reliably under operational conditions. Additional steps include reliability verification, post-implementation testing, warranty management, and staff training, all of which ensure that the system operates smoothly and that personnel are prepared to manage it. However, the life cycle of a security system does not end after installation. Security programs must include follow-on activities, such as corrective maintenance for repairs, preventive maintenance through scheduled inspections, and periodic evaluations to assess system effectiveness. Over time, organizations may also undertake system upgrades or replacements to address technological changes or evolving security requirements. These activities ensure that the security system remains effective, reliable, and aligned with organizational needs throughout its life cycle. As we conclude this overview of Module 5, Physical Security, it is important to recognize the value of the reference resources included in the appendices. The first appendix contains key terms and definitions, providing clear explanations of the terminology commonly used in physical security management. The second appendix highlights high-rise building considerations, which address unique security challenges such as vertical access control, emergency evacuation planning, and integration of security systems across multiple floors. The third appendix focuses on standards in security, offering an overview of industry guidelines, regulatory frameworks, and best practices that shape modern security programs. Together, these appendices serve as valuable reference material for security professionals and CPP candidates alike. This brings us to the end of the Module 5 content overview. In the upcoming videos, we will explore each chapter in detail, breaking down concepts, examples, and practical applications to help you fully understand this critical domain of the CPP certification. If you found this overview helpful, please like the video, subscribe to the channel, and turn on notifications so you don't miss the upcoming chapter-wise lessons on physical security. Thank you for watching, and I look forward to seeing you in the next video.